This tutorial we will learn about MongoDB and its core components, MongoDB Replica Set, application scalability, Sharded Cluster and its components, architecture of MongoDB Sharded Cluster with multiple replica set, and last but not least, deployment of MongoDB Sharded Cluster on AWS Live environment. First, let's understand what is MongoDB. MongoDB is a cross-platform and open-source document-oriented database. And why it is called document-oriented database? Because MongoDB stores data in JSON document format, which is similar to JSON. Basically, JSON is a binary representation of JSON with some additional type of information. MongoDB provides high performance, high availability, and automatic scaling. Core components of MongoDB. MongoDB has three core components. First one is MongoD. MongoD is a daemon program which runs quietly in the background on your machine. It is responsible to handle the data request, manage the data access, and other background operation. Second one is Mongo, which is a default command line client or an interface for MongoD. You can use MongoD shell to connect to your MongoDB server locally or remotely and perform database as well as administrative operations. The third and last one is Mongoose. Mongoose runs on an application server and play a role of query router for Sharded Cluster. In Sharded Cluster, data are distributed among the multiple servers. So the role of Mongoose is to communicate with the configuration server and to determine where the requested data is, and then fetch the data from the shards and aggregate that data and return it back in the JSON format. Replica set. A replica set is a group of MongoDB servers that maintain the same data set and provide both redundancy and increased data availability. It is a best practice to keep the replica set on production environment so that data failover can be handled easily and quickly. Replication process in MongoDB ensure that the same data is available on two or more MongoDB servers. So in case if your primary instance goes down due to whatever reason, your secondary instance could be promoted as a primary without any data loss. In each replica set, there is one primary server and one or more secondary servers. So basically, primary server is responsible to accept all the write operations from client. Secondary server can be used primarily for all read operations. So in that way, you can reduce the workload of your primary server by routing your read queries to the secondary instances. But here I would recommend that to use primary server where you need read data immediately after write, because replication happens asynchronously by copying the primary log and repeating the same changes to the secondary dataset. And read from the secondary node can result in old data being served. Replica set provides high availability using the automatic failover. Failover allows a secondary member to become a primary if current primary goes offline or step down. Here in this diagram, you can see the representation of replica set. Here we have one primary and two secondary nodes, and all of them are a part of single replica set. Basically, primary node is responsible for all write operation and then changes further replicated to the secondary nodes. However, you can use primary as well as secondary for read operations. The main objective of replications are to keep our data safe by spreading data across multiple machines. Improve data durability guarantee so that data could be accessible at all the time. Disaster recovery. improve read performance by introducing multiple read slips. No downtime for maintenance activity like backups, index rebuilds and compaction. Our next topic is scalability. The main objective of sharding in MongoDB is scalability. A server's capacity can be challenged by database system with a large datasets or high throughput applications. Sometimes single machine is not sufficient to cater the business needs. For example, high query rates can exhaust the CPU capacity of the server. Working set size larger than the system's RAM can stress the input-output capacity of the disk drives. So before moving further, let's understand what is the scalability. Scalability is the capacity of a system, network or a process to grow and manage the increased demand of work. It means function should work well when it is changed in size or volume in order to meet the user need. If we are building in an IOPS intensive application with large dataset or high throughput, then it's become mandatory that your architecture should be scalable. A scalable architecture is an architecture that can scale up to meet the increased workloads. In other words, if the workloads all of a sudden exceed the capacity of your existing software plus hardware combination, then you can scale up your system with your software and hardware to meet the increased workload. There are two types of scalings. First one is vertical scaling, which is also called scale up. Second one is horizontal scaling, which is also called scale out. Vertical scaling. Vertical scaling means that you can scale up by adding more power with CPU, RAM or storage space to your existing machine. Vertical scalability costs rises sharply after a certain period of time. Here you can see the visualization of vertical scaling. Horizontal scaling. Horizontal scaling means that you can scale by adding more machines into your pool of resources. With horizontal scaling, we can divide the system dataset and load over a multiple machines. Horizontal scalability can be achieved with the help of clustering, distributed file system, and load balancing. Cloud service providers like Amazon, Azure, Microsoft Azure, and Google Cloud Platform are providing some auto-scalable models which are smarter than the traditional scaling models and gives you the best performance and with no downtime. A scalable architecture is an architecture that can scale up to meet the increased workloads. Here you can see the visualization of horizontal scaling, where more machines are added over a period of time. Sharding. MongoDB supports horizontal scalability, which can be achieved with the help of sharding. Today, in this lecture, we will see how to implement MongoDB Sharded Cluster on AWS server. But before that, let's understand what the sharding is. Sharding is a method of distributing data across multiple machines. MongoDB uses sharding to support deployments with very large dataset and high throughput operations. Sharding is a method used to allow MongoDB to scale horizontally, which means that data will be distributed and split into range and then stored in a different shard which can be located in a different server. Shard keys are used to determine how the data will be distributed. Now let's come to the sharded cluster. Sharded cluster has three main components. First is config server. Configuration details and metadata are stored in config servers. Metadata stores the information about the locations of the data chunks, which is important since data will be distributed across the multiple shards. Each production sharding implementation must contain exactly 3 configuration servers. This is to ensure redundancy and high availability. Please note that use of 3 mirrored MongoDB instances for config server has been deprecated from MongoDB 3.2 version, and now config server has for sharded cluster can be deployed as a replica set. MongoDB 3.0 and earlier version supports only single server deployment protocol, which is called SCCC, which is deprecated from the MongoDB 3.2 version, and now it is supporting a new deployment protocol which is called config server as a replica set, CSRS. The next component is Mongos. As we have already discussed in previous slide, Mongos run on an application server and play a role of query router. The job of query router is to process the queries from the application layer and communicate with the config server to figure out where a given piece of information is stored into the sharded cluster. It is then access and return the data from an appropriate shards. And the third component of MongoDB Sharded Cluster is shard. A shard is simply a database server that contains a subset of sharded data. In production environments, a single shard is usually composed of a replica set instead of a single machine. This is to ensure that data will still be accessible in event that a primary shard server goes offline. Items in database are divided among shards either by range or hashing. Architecture of sharded cluster. In order to design the architecture of MongoDB Sharded Cluster with replica sets, the answer of a few questions are required initially, like how many shards are required? It means how many partitions do we need of our dataset? How many replica sets are required in each shard and config server? It means how many copies of each shard or config server are required in our cluster. How many query routers are required? It means how many application server or Mongos you have required initially to manage your traffic. Basically, answer of these questions are depend upon workload, data size and the availability of your resources. Initially, you can start with bare minimum requirement, and later on you can add up or remove the resources based on your application traffic and data size. For production deployment, it is highly recommended that you must have a config server replica set deployed on 3 or more different machines. You can have 2 or more sharded replica set and each replica set deployed on 3 or more different machines. Again, it's depend upon the size of your data and how many partitions you have required of your data set. You can have 1 or more Mongos process running anywhere in your environment. We can better understand this with the help of diagram. And this is the representation of architecture of MongoDB Sharded Cluster with replica set for production deployment. Mongos could be run anywhere. We can run it on sharded server. We can also run it on client application machine or anywhere else. It would be better to keep the Mongos into your application server so that it will reduce the latency between the Mongos and our application server. Since Mongos has no persistence stage, you can run Mongos process as much as you want and shut it down when they no longer required. You can also use the load balancer to manage and distribute the traffic among the different Mongos machines. So friends, if you can see here in this diagram, we have 2 Mongos processes running on 2 different servers, and these 2 servers are sitting behind the load balancer, where load balancer is responsible to manage and distribute the traffic between these 2 servers. As I explained in the earlier slides, that for the production sharding implementation, we have required at least 3 configuration server which we can deploy as a replica set. We use replica set for both redundancy and increased data availability. In each replica set, we have one primary and one or more secondary servers. Here you can see that we have one primary and two secondary servers. In this implementation, our data is distributed over the three shards, shard 1, shard 2 and shard 3. Under each shard, we have three servers, one primary and two secondary, and which are deployed as a replica set. Where a primary server who is responsible for the write operations and secondary which we can utilize for the read operations. As we have already discussed earlier that MongoDB replica set support high availability and automatic failover. It means if any one of my primary servers goes down due to any reason, then based on the priority of secondary servers, any one of them can be promoted as a new primary server. But note that this transition will take a little bit of time, and during this period of time our write operation would be guarded. However, it has no impact on our read operations. And if I want to deploy the same architecture on my production environment, I would require 14 independent servers, 2 for Mongos, 3 for config servers and 9 for our shards. But since this is in a demo session, so I am not going to use that much of servers. In this lecture, we will configure a sharded cluster with replica set that contains 2 config servers, 2 shards with 2 servers in each replica set and 1 query router. To implement the same architecture on our AWS cloud, we would have been required 7 separate instances, 1 for Mongos, which is our query router, 2 for our config server and 4 for our shards. Before moving to our practical session on AWS cloud, let's take a look into the MongoDB default ports. MongoDB uses 27017 port for both MongoDB and MongoS services, 27018 for shard server and 27019 for config server.
In this video, I will show you how can you install or launch an EC2 instance on AWS and install MongoDB into it. But before moving further, let's recap what we have learned so far. In our previous video, we learned about what is MongoDB and its core components and how can we maintain the same dataset in different physical locations with the help of replica set to provide both redundancy and high data availability. Also, how can we achieve scalability in MongoDB by implementing horizontal scaling. Also, we learned about sharded cluster and its core components and how it is helping us to distribute the large data set across multiple machines. And last, the architecture of MongoDB Sharded Cluster with replica sets for production deployment.
Now let's move on to our AWS console to deploy this architecture. This is AWS Services dashboard, and on top of this page you have the option to select the region. Here I have selected Asia Pacific Mumbai region. You can select your nearest region. Under the compute section, click on EC2. And as you can see that there is no instance running currently in my selected region. And now the very first thing we need to do is to create our security groups. So just click on security group link here. As you can see that I have a default security group here. In default security group, I have allowed SSH access to everyone. However, you can restrict it with IP or with security group. For MongoDB Sharded Cluster, we will create 2 new security groups. First, for internal communication between nodes in our cluster, and second, for allowing our application to communicate with the MongoDB database. First, I am going to create a new security group for my MongoDB instances for internal communication. So I clicked on that link. So I have to specify the name of my security group. So I have given name like copy the same thing in my description. Click on add rule button. So as you know that we have 3 ports which should be allowed, so I'm entering the port range over here. Initially I am allowing for everyone and put the same description over here and create, and click on create button. So as you can see that a new group, security group has been created. Okay. Since we created this security group for internal communication between the nodes in our cluster, so we have to restrict the external access. So which we can do by copying the security group ID and then edit the security group and then paste that security group ID here. In this way, all the instances within this security group can communicate to each other. We have restricted the external access because we never want our shard server, our configuration server should be accessible to anyone beyond this group. Now let's create a second security group for external access so that our application server can communicate with our MongoDB database. Just click on this. I've given that name MongoDB external access. Copy the same thing in description. Now click on this port and now to specify the port, which is 2027017, and it should be accessible to anyone. Now our security groups are ready. Let's go to the instance section and launch our first instance. So as of now, no instance running in my region. Just click on the launch instance button. Here you can see the list of AMIs which is offering by the AWS. So you can choose as per your requirement, but I am going for the first one. In this section, you can see the bunch of instance family names like general purpose, compute optimize, GPU compute, memory optimize. But if you are going to build a high traffic database where you need a very high performance with a low request latency, so I would recommend here to go with storage optimized instances, which is especially designed for the NoSQL database. But for this demo, I will go with the general purpose T2 micro instance, which is come under the free tier. Here the number of instances is 1, and this is my VPC, and this is my availability zones. So I'm not going to specify any availability zone, so I am keeping everything as it is. Let's move to the next section. In this section you can increase the size of your root volume as per your requirement. Volume type in general purpose volume SSD can give you up to 10,000 IOPS per volume, and if you require more than 10,000, you can select provision in IOPS SSD volumes, which can give you up to 20,000 IOPS per volume. Here I am going to add a tag for my instance and volume, and this would be our first config server. Here I have to associate my here I have to select the security groups. So I am going to select the existing security group which I have created earlier. So I am going to select default, and so that my instance could be accessible through the SSH and the internal security group. Everything is fine. Now launch. So here I will go with my existing key pair which I have created earlier. This, acknowledge it, and this. Now my instances has been created. Here you can see that. Now my instance has been created successfully, and here you can see the instance state. Now let's connect to this instance through SSH and install MongoDB on it. I am going to install the MongoDB Community Edition on my AWS instance. You can also check out the MongoDB installation steps on MongoDB official website. If I go down a little bit, here you can see the list of packages which are officially supported by the MongoDB in their own repository. You can install any of these packages selectively, and if you want all of these packages to be installed in your server, then just install MongoDB org, which is a meta package, and it will automatically include all the packages which are listed below. For the installation of MongoDB on our AWS server, first we need to configure the package management system. And for this, we have to create a MongoDB repo file under my yum repo directory. And now copy and paste the following content in your repo file. Now clear it and type this command. This command will update the existing packages and then install the MongoDB in our server. Now if you want MongoDB to start at boot, you can issue the following command. We have set up our first server in which MongoDB is installed. Similarly, for our cluster system, we need 6 more servers with the same setup. So now I am going to create an image of this instance which I will be used as a source in the creation of other instances. So that for the remaining servers, we don't need to install and configure the MongoDB again, and it will save our time. Now let's go back to our AWS console again and create our AMI. Now here select your instance, click on the action button, go to the image section and then click on the create image link. Here I have to mention my image name. Here enter the same name in the description and then click on image, create image button. So my image has been created. I can see my image in AMI section. Here you can see that it is still under progress. It will take a little bit time. Now the status has been changed. Now we can use this image. Now I am going to create my second instance with the AMI which I have just created. Click on the action button and then click on launch. Next. Here I have to mention the tag name. This would be my config server 2. Existing policy, default and internal. Everything seems fine. Launch. I'll choose my existing key pair. Launch. Now my second instance is also being launched. Now my second config server is also ready. Similarly, I am going to create 4 more instances for my shards and 1 for my query router. But till that time, I am going to pause this video. Friends, as you can see that we have now 7 servers and which are running. 2 servers for our config servers, 1 for Mongos and 4 for our shard servers. And I explained earlier that from MongoDB 3.2, config server for sharded cluster can be deployed as a replica set. So our next step is to create a config server replica set for redundancy and high availability. Now I am going to connect with my config servers one by one. Now I have connected with my both config servers. Now we need to create a data directory where the configuration server will store the metadata that associates the location and content. And now we have to set the ownership of this folder. MongoDB runs under the MongoDB user and group. Now we have to specify the MongoDB settings, which we can do either via configuration file or the command line. We can start configuration server with a very easy command. So we have to specify that this server is a config server and with replica set. I am giving the replica set name CSR and I have to specify the DB path. And the port. Default port for config server is 27019. Also need to mention the log path. And if you want to run this process on background, so just add for. Now if you can see that our Mongo process is running. We have run our MongoDB config server with the command line, but there are the chances of error. So we can eliminate the chances of error by specifying the setting into the configuration file. So let's kill this process and try to set up our configuration server with configuration file. MongoDB config file is located at this path. In this file we have to change the DB path as per the directory which we had created. And now the port, because config server is running on 27019 port, and comment out this line so that config server could be accessible from anywhere. And now since this is we are deploying a config server as a replica set, so we have to mention the replica set name over here. So my replica set name is CRS, and have to comment out and comment this line as well. Since is a part of sharded cluster, so I have to specify the role of this particular instance. And that's it. Now start the MongoDB daemon by specifying the configuration file path. And log path. And here you can see that our process started. Now you can check your process by so here my MongoDB daemon is running. Similarly, I have to configure my second config server. First, we need to create a data directory. Now we have to set the ownership of this folder. And now we have to configure our config server. First, here I have to change the data directory path. Then port, need to comment out this line. Set the replica set name. Okay, and then sharding, and comment this line. Need to mention the role of this server. And that's it. Our second configuration server is now set up. Now let's start our second config server. Now our second server is started. We can check the port of our MongoDB process with this command. So here you can see that currently my MongoDB daemon is running on 27019 port.
Now connect a Mongo shell to one of config server members by specifying the port number. To deploy our config servers as replica set, we have to initiate the replica set using the rs-initiate method and a configuration document. And here, as you can see, that I mentioned the ID of my replica set as CRS, and since it's in a replica set of config server, so this variable config server is true, and I have added both of my config server as the member of this replica set. So here you can see that the IP of my both instances. Now we can check the status of our replica set. And as you can see that in this replica set we have two members. First one is primary and the next one is the secondary.
Our config server with replica set has been created successfully. Now similarly, how we have created our config replica set, I am going to create two shard replica sets. In each replica set we will have two members. But till that time I am going to pause this video.
And here, as you can see that I have opened all of my 4 instances in different tabs, which I am going to use as a member of our sharded replica set. So here, as you can see that first 2 instances are the member of shard1 replica set and the next 2 are the member of shard2 replica set. We can start our shard member by using the following command. Here you can see that the name of the replica set is rs0, and I have mentioned the DB path and the port number where my service will be running. But as we did earlier, for the config server, we will use the configuration file to avoid the chances of error and make the changes permanent. So let's move to the config file and see what are the changes required to set up the shard replica set. To make it cut short, I have already created the data directory, changed the ownership of this directory, and updated the configuration file for all the members of the shard1 and shard2 replica set. If you notice the difference between the config server and shard server configuration file, you can find that there is a difference in the port number. So as I mentioned earlier, that config server is running on 27019 port and shard server is running on 27018 port. Another difference is in the name of replica set name. So here I am using rs0 as the name of my replica set for shard1. And the last difference in the name of cluster role. So here I have updated shard server because I am going to deploy this instance or a machine as a shard server. Similar configuration is required for other members of the replica set, but make sure that the replica set name should be different for different shards. If you see the configuration file of replica set of shard1, shard2, you can find that there is only difference in the replica set name. Here rs0 is the name of replica set for shard1 and rs1 for shard2. Remember that the name of replica set name should always be same for all the member of a same shard. Now configuration part is done. Let's start the MongoDB services in all these instances. Now MongoDB service is running on all these instances. Next step is to deploy our first shard replica set, and for this we have to connect to Mongo shell to one of the members of our first shard replica set. Now we can deploy our first shard replica set by using rs_initiate method and a configuration document. So here you can see that I have given my name of my replica set as rs1 and the members details like the IP address and the port number. So here you can see the private IPs of my replica set. So you can check the status of a replica set by rs status function. Here you can see that we have one primary and one secondary member. While initiating the replica set, this rs_initiate method triggers an election and elects one of the members to be the primary. In similar way, we can launch our shard2 replica set. So here I have mentioned my replica set name and the IPs of my other instances, shard2 instances. It's launched successfully. Now we can check the status of the replica set. Here we have one primary and one secondary. Till now we are able to configure our config replica set to shard replica set, and each replica set we have two members. Now our next step to configure Mongos and connect it to sharded cluster. As I already explained in my previous videos that Mongos plays a role of query router in MongoDB shard configuration, and it determines the data location in the sharded cluster. So Mongos can be run anywhere, and we can run it on shard server. It could be run on client application server or anywhere else. But in this video we will configure Mongos in a separate instance. Let's connect to this instance. For Mongos we need one additional package. Please note that if you have already installed the MongoDB org package, then this package is not required. Now we have to specify the Mongo setting, which we can do either via configuration file or command line. With command line we can run Mongos with this command. Here I am giving the config server replica set name and the details of members of the replica set. But here as well we will not use the command line and go with the configuration file. Okay, let's open the config file and update the configuration setting. But before that, let me copy this config server replica set name and its member details. Okay. So first thing we have to do is to comment out this storage section, since no storage is required for this Mongo's router. Okay. Next thing, this port number is okay because Mongoose is running on 27017 port. So just need to comment out this line. And here in the searching section, since we have to update the configuration config server replica set name and its member detail, so we have to add a variable over here. So I am pasting what I have copied earlier. And that's it. Now we can start Mongoose by using the following command. Let's look. Everything seems to be fine. Oh, there is a typo error. We need to put a space. Let's try it again. Yeah. And now connect Mongoose L to Mongoose. And now the last step of the process to add each shard to the cluster. And for this we have to use the add shard function, and here I have given my shard name followed by hostname and port of members of the shards replica set. Now I am going to add each shard to the cluster one by one. But before that, let me remove the extra space between them. Okay. Yes, we all set. Now you can see the list of your shard by using the following command. Now here you can see that we have two shards and the details are mentioned here. Our sharded cluster with replica set has been configured successfully. Now to use our sharded cluster, the first thing we have to do is to enable the sharding on database level, and for this we have to create a database. I have given testdb as a name of my database. We can check that we are currently using the database we just created by typing this command. So as you can see that we are currently on testdb database. And now let's enable the sharding for this newly created database, and for this we have to switch to the admin database. And now need to run this command. Enabling sharding for a database does not redistribute the data, but it make it possible to share the collection in that database. Once you have enabled the sharding for a database, MongoDB assign a primary shard for that database where MongoDB store all the data in that database. And hence, for the distribution of data among the shards, we have to enable the sharding on collections. We can enable sharding on a specific collection, and a database can have a mixture of both sharded as well as unsharded collections. To enable the sharding on collection, we need shard key. Actually, shard key determines the distribution of collections document among the clustered shard. Shard key could be indexed field or index compound field which exists in every document of the collection. Please note that once you shard the collection, you could neither change the shard key fields nor update its values. Actually, selection of shard key affects overall efficiency and the performance of the operation within the sharded cluster. Okay, let's take an example of e-commerce portal where you have lots of product data. Then you can shard the data by using the product category or type, and this will help if your query is based on particular product type or category. But if your query's category is very limited, then it is not advisable to use it as a shard key. In such scenario, we should use hash ID as a shard key. Okay, let's discuss a little bit about the sharding strategy. So there are two types of strategy basically. First is hash based sharding, where the collection data is partitioned into the chunks, and then based on the shard key, values of each chunk is assigned to a range. And second strategy is range sharding, where the collection is divided into the range, min and max, and determined by the shard key. When you have to partition the data on the basis of salary, age, population, or any set of range, so in that case you can use range sharding. And for more information about the sharded keys, you can visit the below URL. To populate some data in our collection, I have downloaded mock data from this site, and here you can see the list of fields we have in this mock data. And here in this collection, I am going to use state as a shard key of my collection. Now let's go to our Mongo server and create this collection with shard key. And here the name of my collection is users and my shard key is state. Now switch to our test DB and populate some data. Now our records are inserted. Let's run the find query. And here as you can see that the records are coming. So we are successfully deploy our sharded cluster and populated data as well. Terminating a MongoDB instance, either a config server or a shard server, will have no effect on the availability of the data and the ability to perform all the operation on it. But here all of my instances are running and responding. Here you can see that 2 config servers, 4 shard servers and 1 Mongo server. If you like this tutorial, then please like this video and don't forget to subscribe Cloud.